You ever wonder what the world would be like without DNS? I'd be saying things like, dude, did you check out 53.11.33.2? They've got some crazy solid state disk prices. Or, did you see that post from Sally on 4.33.1.1? That was hilarious. I could so do this all day. So you get the point, right? DNS is obviously fundamental to the way we do the internet and the way that we do internal name resolution. But it's so fundamental, most people don't even think of it. It's like the foundation of your house, right? Concrete slab. It's essential. If it doesn't work right, your house falls over. But I don't sit here walking around going, oh man, this slab is awesome. It's what I walk on. It's the same thing in the DNS world. But what most people don't realize is that DNS can be a huge single point of failure, and it can be a huge performance bottleneck for your system. So that's what we're here to talk about. How do we do DNS the right way? It's called Route 53 from Amazon Web Services. So we'll look at Route 53, what sets it apart from the rest. We'll look at the foundation elements of DNS, the kind of the core records and the core functionality of it. And then we'll get into some of the misunderstandings of Route 53. Here are the do I know this already questions. So if you can look at these and know the answer, you probably don't need the information that's in this nugget. Otherwise, let's get started. Well, as we get started, I don't want to assume anything, right? What is the domain name service? What is DNS? Well, you and I are human beings. We think creatively. We think in colors. We think of beautiful things and joy and all of the different things that makes us a human being. It's not how computers work. What do computers think of? Yes, no, yes, no, yes, 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 no, yes, no, on, off, 1, 0, 0. They're very fast at processing very simple on-off logic, right? And when it comes down to accessing resources, we think in terms of names like Amazon.com to go buy my solid-state hard drive, or CBTnuggets.com to get my training. We don't think in terms of IP addresses. That's what made that introduction so absurd when I said it. So how do we blend the two? DNS. DNS takes these user-friendly names and translates them to an IP address. So whenever I access a resource, any resource that I'm accessing by name, the very first thing that my computer does is look up the IP address. Check this out. I'm going to bust out Wireshark, which is a nitty-gritty troubleshooting tool, and capture the packets coming from my network card so I can see everything that my computer is sending and receiving. Then I'm going to drag a command prompt over into the picture and do a ping to www.cbtnuggets.com. Good. So we got some responses. I'm also just going to come in here and do a ping to google.com. How about that? There we go. Got a couple of responses in there. Okay, stop the capture behind the scenes. What really happened? Now I scroll up and I see these ICMP messages right here, which are the pings. Little known fact that when you ping something, it actually sends the entire alphabet, and you can see the data right there, A, B, C, D, F, G, H, I, J. So it sends the entire alphabet to the other side, and the other side sends the alphabet back. That's the ping request and reply. But look what happened right before that. Check it out. My computer, 172.30.100.223, sent a DNS request. You see the DNS right here to the destination 4.2.2.2. It says, excuse me, DNS server, who is, standard query, cbtnuggets.com. See this little A right here? It's actually asking for the address record. It's saying, who is cbtnuggets.com? Then look at the next packet. Just 100 milliseconds later, it flipped back around and said, oh, dude, cbtnuggets.com is actually this guy. Which isn't a good example for this very introductory one. It says actually cbtnuggets.com is e6430.dsa. That's another DNS name. Essentially it said this is hosted at another entity. So the DNS server said, you know what, I'm going to save you the trouble because I know what you're looking for, computer. So I'm also going to send you the IP address, or the A record, address record, for that e6430.dsa. You can see it's 184.86.20.151 happens to be the IP address that ended up responding to ping right here. We could go further down and see us probably, yep, right there, do a DNS lookup for google.com. It's saying, hello, who's Google? This guy comes back around and says, oh, actually, Google is this and this and this and this and this. It actually gives you a whole bunch of, look at all, good grief, Google, how big are you? Anyway, that's DNS. DNS is so fundamental to making our computers work, right? So what makes the way Amazon does DNS unique? Well, before I even answer that question, let me back up even further and say Amazon does offer DNS services. They call that platform Route 53, which is very witty because DNS actually runs on UDP port 53. So what makes it unique? Well, number one, it is built for Amazon Web Services. You'll see it integrate into Amazon Web Services in ways that other DNS servers do not. They even have a proprietary record called an alias that allows you to point specifically to AWS resources, not actually just point to the IP address of them, which kind of makes it a benefit because it starts hiding some of the complexity behind the scenes and really making complex processes simple. Second thing is that you are using the same DNS system that Amazon uses themselves. It is a worldwide, distributed, Anycast-based DNS. Okay, explain that. Worldwide, meaning there are DNS servers around the world, distributed, being that they are redundant, they are load balancing, and you can guarantee you that you're going to get the fastest DNS response ever. Here's the fact, and this was what I was alluding to on the very opening screen of this nugget, is that DNS can cause major performance issues. If you are running DNS yourself and you bog down that server, you ever this is on the fly, I'm just thinking. You ever gone to a website and at the bottom, let's see if I can capture, everything moves so fast. Let me go to, what's a good website of it? www. Let's just go msn.com. See down here? It's going too fast. But do you see the little thing at the bottom right, bottom left corner? Let's go to yahoo.com, right? Right here, and it shows, it's just kind of flashing up. I gotta be careful here. Anyway, what in the lower left corner of your web browser, try it yourself. You actually will see it giving all these little flyby status messages. And if DNS is slow, you'll actually see it hang there saying, oh, trying to look up yahoo.com, for example. And it'll hang. Your website is not showing up, giving your customers the impression that your website is slow. Your website could be blazing fast running on Amazon Web Services. However, if DNS responses are slow, then that causes your website to run slow. Now, what could cause DNS to go slow? Well, number one, your server could be overloaded. That could happen with anybody. But second off, you could be hosting DNS in a location far, far away. See, a lot of people host their websites, say, at like bluehost.com or godaddy.com, some of these, really inexpensive website hosting providers. Well, the fact is they have one location providing DNS. And if you have somebody on the other side of the world trying to resolve that name, trying to look up your website on bluehost.com, it actually has to go all the way to the United States and all the way back every single time it does a DNS lookup. And that's before it even sends any data. So distributed means that you get DNS servers close to everybody, thus the Anycast. Anycast, what is that? It's pretty awesome. Anycast is actually where you assign the same IP address to multiple servers. Now initially you might say, well, that's not possible. You can't do that. Actually it is. Anycast is designed for IPv6, but people are using it for simple services like DNS and IPv4. Essentially, here is, let me see if I could explain the big picture, very simple. Here's Amazon Autonomous System number. Autonomous System deals with what IP addresses Amazon owns, right? They go and register for an autonomous system number. It deals with BGP, the Border Gateway Protocol. It's how they do routing on the internet. And essentially what they do is inside their system, they'll say, okay, well, I've got a DNS server here that's, let's just say, 1.2.3.4, right, in our system. I then go create another network. Maybe it's on the other side of the world. Maybe it's even in a different autonomous system, depending on how big Amazon is. But I say, I've got 1.2.3.4. And then over here on the other side of the world, we create another DNS server, and I've got 1.2.3.4. Now, I know if you're a network engineer, you're like, it's like spooning my heart out with something painful. I don't know where these things come from, right? You can't do that because it's duplicate. Well, actually, you can. With BGP, it can have multiple routes to the same destination. That's how the internet works. You have redundancy upon redundancy. So what you can do is have all of these uplinks, right, all around the world to where your DNS servers are located. And, Amazon connects to, I don't know, level 3, let's say Time Warner. I'm just throwing other service providers. I don't even know what Amazon's connected to. I'll just say Sprint and AT&T and all these different carriers in all these different regions of the world, right? And those carriers connect to the customers, and the customers connect to other customers and customers, and so on. So when somebody does a DNS lookup and says, hi, I'm looking for www.cbtnuggets.com, well, what it's going to do is just find the closest route to 1.2.3.4, which happens to be the DNS server hosting cbtnuggets.com. Does that make sense? I know that's like a that's a flyby explanation of what any cast-based DNS is, but the good news and the simple way to put it is it just finds the closest DNS server to you. Okay, what else can Route 53 do? DNS health checks and failover. This is so awesome. Not all DNS servers support this. Surprisingly, very few of them do. When you have your DNS server, the core record that you create, as we saw from that demo I just did with Wireshark, is the A record, the address record. And we saw, for instance, when I looked up Google, right? And actually here, I'll show you another cool tool. NS Lookup gives you the request response feel of what things are. So when I type in google.com, you see it's like, bam, all of these different IP addresses show up, even an IPv6 address, because that's the road that we're headed is over to IPv6. Well, why, how, huh? Well, Google has a ton of redundancy, obviously, in their system and load balancing and all that. So what happens is they take that one google.com and point it to all these different IP addresses. Well, that's great until the server with the IP address, whatever, just take one of those guys. This guy dies. Well, DNS, the way the requests work is when somebody looks up google.com, it actually rotates these in a round-robin format. So the first person will get this one as their first address and try to use that server. The next person will get that one. The next person will get that one. It's a pretty cool way of load balancing until you get to that server, which is actually on fire right now, and it's down. What happens then? My screen just blinked when I did that. Well, at that point, every, eighth person that gets a lookup gets a dead response. Well, not with Amazon health checks. The DNS server can actually actively connect to each one of these, either a simple ping message, or you can even have it connect to certain services. Like we know HTTP runs on TCP port 80. You can have it check, say, once every 60 seconds, hey, is this guy still running? Is it on fire? And if it stops responding, it can actually pull that DNS response out of there. It will no longer list that server in the A records until it comes up for whatever amount of time that you've specified. That's the failover. It's awesome. Global traffic. Route 53 gives you lookup mechanisms unlike other DNS servers, like latency-based routing, to where I can look up and say, what is cbtnuggets.com, and it will actually respond back to me with the server closest to me in terms of latency, how fast I can get to that server. Right? You have weighted round robin to where, let's say in AWS, you spin up a couple monster instances, giant, meant to handle most of your requests, and then a couple little micro instances. They're there for redundancy. They're there for backup. Well, using DNS and weighted round robin, I can say, you know what? I want 40%. That'd be a 40% of the responses to point to this server. 40%, so now let me make sure I'm filling in the cracks. When somebody looks up cbtnuggets.com, 40% of the responses will point them to the IP address of this server. 40% of the responses will point them to the IP address of that server, our two monster servers, and we're load balancing well. You see where I'm going here, right? Then these other two get 10% each. So that way I can make sure that I keep those things alive. I make sure that they're working in case something happens to my monster servers. I can always increase the instance size here and give them some live traffic, but I don't overwhelm these little micro servers nor crush my budget because I don't want to pay to run the 4 monster servers behind these. So that's what weighted round robin is. GeoDNS. GeoDNS allows you as the admin of Route 53 to come in and assign your instances essentially to specific regions of the world. So I can say, when somebody in Taiwan looks something up, I want it to go to this server. And when somebody in Africa looks something up, I want it to go to that server. And you can actually specify based on where they're coming from in the world because Amazon has a giganto database of all the IP addresses. And so when they see a source IP address coming from a computer, they can look up and say, oh, okay, well, let me point you over to this server because that one's the one that we intended for Africa. Now, I know you're probably thinking, well, that's awesome for performance, right? Because you can pick the server in Africa that you want. Well, yeah, but also think about what do they call that? Linguistics, language. There's there's a term, you know what I'm talking about, right? To where you can actually have the website show up with different languages based on where you are. As a matter of fact, I had this instance with Microsoft. I was supporting a server that I had to call Microsoft support from, and I opened the web browser on the server, which happened to be in another part of the world, and it showed up in Spanish. The website showed up in Spanish, and I thought, oh, I can't understand this. So I had to minimize and open the web browser in my local region so I got the right language. Before we go any further, I want to mention that Route 53 is an excellent starter service for Amazon Web Services. You can run Route 53 independent of all the other AWS services. It's how I got started with Amazon Web Services many years ago. I hosted all my stuff, and still do, actually, off of Bluehost.com, all my personal blogs and file stores and stuff like that, off of Bluehost, but I wanted the DNS lookup capability of Route 53. So I signed up for Amazon Web Services. I transferred my domains over and used Route 53 to manage that. So now if somebody in Africa wants to go to my blog, because I know everybody in Africa wants to go to my blog, but they might. So they can actually get a super fast response time from Route 53, but then they, of course, have to travel all the way across the world to California to the actual server hosting my blog, right? So Route 53 can be run totally independent. Now, here is how the core of DNS works, right? DNS obviously holds billions of domain names out there. There's no one database big enough to really store all of that information and provide response time. So DNS, it's actually a modern wonder if you think about it. You actually have the database of all these records replicated between thousands and thousands of servers all across the internet, and it's still maintained and still kept from duplicates and all of that. So up at the top you have the IANA, who maintains these root level servers, and they keep adding more root level domains, but it all started with .com, .org, .edu, those kind of things at the very tail end of it. Down below that, you have the second level domain database. That's where you get CNN or Amazon or cbtnuggets.com that are looked up there. And then you go further and further. You can get third level and essentially what's called lower level domains. Essentially anything below that second level is considered lower level. And typically you and I create those records all day long. That's the www or FTP or images or whatever we want to do as our lower level domain names. Now, as we've gone through the years and years, our servers have become faster and have more memory and all that kind of stuff. And DNS caching handles most of the request. So when I'm sitting here and I look up cbtnuggets.com, it doesn't actually have to go from my DNS server to the higher level, looking for it's called the SOA record, Start of Authority, saying, who is cbtnuggets.com? Because chances are very good that somebody else out there has looked up cbtnuggets.com before it actually has to get to the server hosting cbtnuggets.com to find the IP address. So the cache on all these servers satisfy most of them. But the theory goes that if I were to look up, let's just say ASDF.com, I'm sure there is one, right? It would go out there and say, okay, well, I'm going to look for the second level DNS server. Does anyone know ASDF? Okay, no. Okay, top level servers, root level servers. Do you know who ASDF is? I'm looking for the Start of Authority. Who is the DNS server that has the authoritative records for ASDF.com, right? And these guys would reply back. Actually, when I was preparing for this nugget, I looked up and I said, well, how many requests do these guys really get? You know, requests that actually make it all the way. And it actually said 2% of the requests, of millions of requests that come to these servers, are actually valid. They're looking for a valid domain name. Everything else is handled by the server. So you go, well, what are the other 98%? Mistypes. People that mistype a domain that doesn't really exist. It'll actually go all the way up to these, trying to find out where is, whatever mistyped domain name that it is. So the dot is what breaks apart the domain name. So cbtnuggets.com. Technically, there's actually a dot at the very end. You see this dot right here at the very end of domain names, but DNS servers haven't required that for years and years. So nobody puts the dot there anymore. The top and second level domain combination is also called the zone apex. So when I type in amazon.com or cbtnuggets.com, this is actually the apex of the zone. Why do I care? Because there are certain DNS records that can and cannot be used for the zone apex. And a matter of fact, this is even changing with Route 53. It used to be that the zone apex could not point to an elastic load balancer. Like you had to have different things for that. Or it could not point to, there was different restrictions on that. Just about all of those have been lifted. However, you will see that documented all the time. Oh, point your zone apex to that address record, or, those kind of things. So you've now seen how the DNS servers work. Now, what do they hold? Well, they hold all different kinds of DNS records. I've broken down what I would consider the core records of DNS right here on the screen for you. These are the ones that we use pretty often. By far, the number one being the A record, the address record. That's when I did that lookup for Google.com. All of these that came back are the address records, essentially direct name to IP address mapping. Not much more to say about it there. The one right below it is AAAA, which is the IPv6 address. As a matter of fact, you see that record right there. When I looked up Google.com, it also said, hey, I'll throw an AAAA record in there, and that only contains IPv6 to hostname mappings. CNAME. CNAME records, as it chops me off, CNAME records are conical names. Essentially, these are a name that point to a name. We saw an example of a CNAME. Do I still have it open? I do. When I did this DNS lookup and I looked up cbtnuggets.com, it actually came back and said, cbtnuggets is pointing to, you see the type right there, CNAME, to this name. So it's a name that points to another name. That's a CNAME. So from there, you can see it took that CNAME. Well, actually, it went for a couple CNAMEs. Take a look. I looked up cbtnuggets.com, and my computer said, I want the A record. DNS server said, I'm not going to give that to you. I'm going to give you a CNAME for cbtnuggets.com.edgekey.net. Then that went to edgekey.net, and edgekey said, well, you know what? I'm going to give you an alias that points to this people. So it's actually kind of bouncing them around to the real server. Will the real server running cbtnuggets stand up? And this guy says, that's me. So he comes back and says, okay, my A record is this. But you see that we actually went through a number of CNAMEs before we got there. MX. Mail exchange record. If you've dealt with email servers, you know this one well. This is where it points where your email server is at. It's used by email clients all the time. Anytime you send an email, it's going to say, I'm going to look up the MX record. Matter of fact, if I were to come over here and type in set type equals MX, and I think I'm google.com, and then just type in google.com, same thing again, and it comes back and says, actually, google.com is handled by this one, and if that one's down, then this one, and if that one's, you see the preference right here, preference 30, preference 40, so a bunch of different things handle, obviously, Google's email, and so that is, that's all represented by the MX record. It tells what email servers there are. Name server record. This is a listing of the name servers for your domain. So when you want to break your domain into subdomains, for instance, I want to go from google.com to www.google.com and images.google.com, it's going to look for the specific name servers for that domain. Check this out. I'm going to do set type equals ns and type in google.com. And you can see there's 4 name servers listed in the public registrar authority for google.com. Now that's actually, let me jump straight from that to SOA, start of authority. Start of authority, if I hit the up arrow on this and type set type SOA and do google.com, you can see that we have one primary name server. So essentially, there has to be one designatee of your name servers that says this is the name server. This is where it all began. This is the main name server for your organization. And this SOA record also contains all the facts about your record. For instance, I would probably say the biggest one is this default TTL, time to live. Meaning, if somebody says, hey, what's google.com's IP address? And someone says, oh, well, the DNS server replies and says, there, 1.1.1.1. It will actually cache that for up to 5 minutes. It says every 5 minutes, I want you to flush it and do a new name lookup just in case. Normally, DNS records don't change, but sometimes they do, right? I might want to change www.google.com instead of pointing to those 3 servers to point to a different set of servers. Well, if all the name servers of the world have cached that, and I have a time to live of 15 days, not that it would let you even go that big, well, that means that there's going to be 15 days before all the cache clears out around the world. Usually 5 minutes is the de facto standard. It's where most people keep it so that the caching servers won't cache that any longer than 5 minutes. Pointer records. Pointer records are, some people call it reverse DNS. So DNS always goes from a name to an IP address. That's the A record. This is the opposite. If I have an IP address, can you tell me what name it belongs to? For example, you can see I'm just looking at this up here. I don't know if there is a pointer record for it, but we'll find out. Set type equals PTR, and I'll type in 4.2.2.2, and it comes back and says, I actually have the pointer record going to that name, right? So it looks it up backwards. SPF records. These are designed to help with email security. Email can be spoofed. I can say I'm sending from whatever email address I want to in the world, which is where a lot of the spam of the world comes from. So I might want to protect my domain. So for example, cbtnuggets.com might say, you know what, we only have it's hard to talk and write at the same time. We only have 3 mail servers, let's just say. Right? 3 mail servers of the world. They are 1.1.1.1, 1.1.1.2, and 1.1.1.3, right? Those are our 3 mail servers. So I'm going to create an SPF record saying these are our 3 mail servers. So if when email goes out, let's just say an email is received by an email server, a lot of them, not all of them, but a lot of them will have what's called an SPF check. And it will say, okay, I'm looking at the SPF of this. Where did this email originate from? 5.5.5.5. Let's do a quick lookup in DNS. Whoa, CBT Nugget says they only send from 1.1.1.1 and 2 and 3. What's this 5.5.5 coming in from? This must be, you guys know where it's going, right? Spam. So it gets trashed before it ever gets there. So SPF records can make sure it's not designed to protect you from spam. It's designed to protect your domain name from being used as spam, so that people can't pretend to be sending those phishing emails. So they say, oh yeah, this is coming from accounting at CBT Nuggets. We need your password, right? Service locator. This one is used. Wow, I like this pen color. It's very hip. Service locator is used for miscellaneous services. I'll say the one that I use all the time is for voice over IP, SIP. SIP services. So if it's looking up where is my voice over IP server, you can create SRV records that say, oh, the voice over IP server is over there. I know Microsoft has some for SharePoint. Essentially, those are just some services that you want to look up. Finally, the ultimate miscellaneous record is the text record. Essentially, if you want to store text in DNS, that's the kind of record you use. Biggest way I've seen this is for verification. Like, you're setting up a domain name. Let's say you're using Office 365, and you say, yeah, I own the domain name jeremy.com, right? Office 365 is going to flip right back around and say, no. You go and you create a text record for jeremy.com and say, Jeremy was here, and then we'll look that up and verify that you really do own jeremy.com, because if you didn't, you wouldn't be able to create that text record. Does that make sense? That's where I've seen almost all of them used. However, you can use them for all kinds of things. It's like an ultimate miscellaneous text record. Last one on the list. Oh, I know. You're like, we were done. No. Alias record. This is an AWS proprietary record, meaning you won't find this record on DNS servers outside of Amazon. What it's designed for is to create a name, let's just say www.cbtnuggets.com, and point it directly to an AWS resource, like an Elastic Load Balancer. Kind of cool. That way you don't need to know what the IP address or DNS name of that Elastic Load Balancer is. I just point www, and you'll see in Route 53 in the upcoming nuggets, we'll get into a configuration. You type in www and you click alias, and it actually shows all the Elastic Load Balancing resources you have, and you go, actually it just points to that one. Very simple. Last thing I want to do is answer some common questions that I've heard about Route 53, just to fix some of the misunderstandings that could be out there. Number one, can I use Route 53 to host my website? Believe it or not, that's the number one question I've got. No, Route 53 is not a website hosting service. Matter of fact, you would have to either A, spin up an EC2 instance, a web server running on there, or you could use Amazon S3. Amazon S3 storage buckets allows you to put images or website files, kind of static website files inside of there. And then I can use Route 53 to point the DNS over to that Route 53 bucket. Then it's a pointer to your website, but it does not host websites. Matter of fact, Amazon Web Services is not a website hosting company. Man, that is just loaded with, I can already feel it, counter arguments that you could say. They are a cloud-based services company, and if you want to spin up a server and host a website from there, you can. If you want to use one of their services like S3 to kind of host your website because it's designed to store files and serve them using HTTP, you can, but Amazon Web Services is not a website hosting company. How fast do DNS changes take effect in Route 53 worldwide? 60 seconds. Seriously, isn't that crazy? So I can update a domain name and it will show up worldwide in 60 seconds. Now, one of the things, and I can say this is very exciting to me, as of this recording, I mean literally months ago from when I'm making this right now, which is the end of 2014, Amazon started allowing domain name registrations. So I went and registered a domain name. Now, normally, if you've ever done that before, you know it's going to be 24 hours. Anytime you register a domain name, it's going to be 24 hours before that goes active, and I was totally prepared for that. 15 minutes. I don't know. I don't know how they do it. I don't know how Amazon allowed me to do that, if they have access to the root servers and some kind of special contract. I don't know. But 15 minutes, I went from not having a domain name into having a domain name that showed up on DNS servers around the world. Now, that's not documented or anything like that, but that's pretty amazing. Does Route 53 use a fixed time to live? What is a time to live? Now, I explained this one on the last screen when I got into the SOA record. Time to live, how long will that DNS lookup be cached for? Do they use a fixed TTL? No. They just have the default 5 minutes for most of their records out of the box, but you can change it to whatever time to live you want. Is Route 53 production only? Meaning, can I create a Route 53 zone that kind of just applies to internal servers? Actually, you totally can. You can create a lab, like you could create, Jeremy.com on a lab set of servers, and I could create a jeremy.com on a production, meaning internet-facing set of servers, so I could have kind of my little set over here, little set over here. That's because you get to specify what DNS servers actually host that zone. So I can have an internal and an external version of jeremy.com, and based on which servers I point to, meaning I can point my EC2 instances to different servers, I can get different responses of what Jeremy.com actually points to. So you might say, well, does that mean I can use Route 53 for private IP addresses? Technically, yes. You can use Route 53 for private IP addresses, but no. Amazon does not suggest, nor I would even balance support. Because you can do it, you can type them in there, and it will take it. However, keep in mind, Route 53 is designed for public DNS. It's designed for people looking things up. So if you have all of your private IP address mapped, that's actually a security dilemma that you have. So if I say, well, my internal cbtnuggets.com actually points to 10.5.1.1, well, you can create, using this, your own little set of servers that host that, but you know what? Those are still publicly accessible servers. And if somebody points to that server, either manually or they just fail over to that server, they're going to get the private version of your DNS name mapping, which is not going to work, number one, but number two, is just not a good security practice. Who knew there would be so much to say about DNS? Such a simple service, right? Look up a name and it returns a response. Well, Amazon has added a ton of functionality to it, which is all beneficial, and that's what we call Route 53. So we have seen what sets it apart from the rest. We went through kind of the core of DNS and then finally corrected some of the misunderstandings. Coming up, we will start seeing the configuration of Route 53, but for now, I hope this has been informative for you, and I'd like to thank you for viewing.